Hello everyone. Continuing with the syllabus of semester 4, paper 9, element of modern physics. Today we'll discuss about the operators, and it can be the operators can be defined as an instruction. Can be defined as an instruction or a mathematical rule, okay, which can be used to change a given function into other function. Okay, so this is what operator is all about. Okay, and it is designated. Operator is designated by hats. It is designated by hats or caps, you can say. Okay, so for example, it can be represented as a cap. Okay, so basically what we have understood related to operator is like any operator, okay, operating on certain function will give you new function. So this is all about operator. We can write it like this: if this one is an operator, okay, a cap, and it's operating on a function fx, so it will give some another function, say b into g as a function fx, where b is a constant. Now this is a basic about an operator which is basically used in quantum mechanics. Okay, so some of the basic properties okay, of operators. Number one is addition. So addition of operator means what? We talk about the addition of operator. It means it is commutative. Okay, commutative and also associative. So if we say commutative means what? It's a plus a cap plus b cap. Operator a plus operator b is equal to operator b plus operator a, or you can say operator a for associative, b operator c must be equal to a plus b operator a plus b plus c. So this is what we do, or what we understand by saying that that is the addition of operators. Okay, now if a cap and b cap are the two operators, and then their sum is also an operator. So means what? If a cap plus b cap, okay, is an operator operating on function fx, then a cap fx plus b cap fx. Now then we talk about the difference of operators, something like this: a cap difference of operator, number 2, minus b cap, okay, fx must be equal to a cap fx minus b cap fx. Again, product of operator. Okay, so again, if a cap and b cap are the two operator, then a cap b cap fx is equal to a cap b cap fx. Here operator b is operating first on a function fx, okay, and then a is operating on the resulting function. So this is what basically it means. Okay, but in general what we can say that it is not commutative. Multiplication is not commutative. Okay, it does follows the associative law of multiplication is something like this. Associative law of multiplication is like a cap, okay, b cap c cap is equal to a cap b cap into c cap. So this is the associative law of multiplication. Then we have equality of operators. Now two operators, equality of operator, what does it mean? Equality of operators. Equality of operators. Okay, so when we talk about equality of operator, we say operator A and B are equal if A operator A operating on fx must be equal to B of fx. Then we have square of an operator. So these are some of the properties of an operator we should have to remember. So what does it mean? It means the square of operator basically is the multiplication of or the product of the operator with itself. Okay, so if we'll say like this, nth power. Okay, so you just multiply it n times. So this is the square of an operator. Then exponential of an operator. Now what does it mean? Exponential operator is a cap. Now we know the series of exponential e to the power x. So likewise what we'll write is like this: 1 cap plus a cap plus a cap is square by 2 plus factorial 2 rather a cap cube by factorial 3 and so on. Now we should have an idea about types of operator. Okay, so types of operator. So here we talk about linear operator. So an operator A is linear. We say like A is linear if it follows this condition. The condition is like operator A operating on fx plus gx gives you, okay, operator A fx plus A operator A gx. So what we can say like this. So this is one thing, and the one is like A operator A alpha fx is equal to alpha operator A fx. Okay, so here fx and gx, f as a function of x and g as a function of x are two function and alpha is a constant Now these two can be combined in a single relation, and that can be written as A operator A alpha fx plus say beta g as a function of x is equal to alpha operator A fx plus beta operator A gx. So it's something like this. It can be written in a single equation, and this, like, this can be written like this. Now we have non-linear operator. So non-linear operator means what? The square root operator, basically. What we can say is like the square root operator. So now this is the square root operator, non-linear operator. Non-linear operator. Okay, so the non-linear operator is the square root operator. We just take an example of the square root operator where we'll say that alpha fx plus beta g as a function of x. This is not equal to alpha fx plus beta gx. So we should have an idea, right? The operator corresponding to all observable quantities have to be linear in quantum mechanics. Okay, otherwise the superposition principle would be violated. So this is the condition. Then we have an identity operator. Okay, when we talk about an identity operator, it means, if operator I is an identity operator operating on psi x, we'll get psi is a function of x, so I will be an identity operator. Likewise, we have null operator. Okay, so the null operator, it signifies the multiplication of a wave function by 0. Okay, so and hence annihilates the function. So we'll have say fx, okay, is equal to 0. Here we should have an idea that the identity operator and the null operator are linear operator. These two are the linear operator. Okay, then we'll talk about inverse operator. Okay, so if for some operator, say A, there exists another operator B, okay, with the property that A cap B cap is equal to B cap A cap is equal to I, then B cap is said to be the inverse of A cap. So this could be written as B is equal to operator B is equal to A inverse. Okay, so the inverse of A cap of an operator A cap is defined by the relation A inverse cap into A cap is equal to A into A inverse A cap into A inverse cap is equal to I. So these are some of the properties and types of operators which we have discussed today, and we'll discuss the eigenvalue, eigenfunction, and other topic related to this portion, the operators part, in the next lecture. By then, thank you very much.